Welcome to Spring LIB.
Okay, so I see that you need help with this question. It says lobster trap placement. Strategic placement of lobster traps is one of the keys to successful lobster fishermen. An observational study of teams fishing for the red spiny lobster in Baja California is conducted, and the results were published in the Bulletin of Marine Science. One of the variables of interest was the average distance separating traps, trap spacing, deployed by the same team of fishermen. Okay, so of interest in this mean trap spacing of red spiny lobster fishermen in Baja California. So it has a sample. So it has 93, 99, 105, 94, 82, 70, and 86. And so you are given the raw data, okay? And so okay, so then it says identify the target parameter for this study. So it's the trap spacing. So trap spacing. And then you have to calculate, so the mean of the point estimate, trap spacing. And so B, the point estimate of the target parameter. So the mean of this is 89.8571. And then we have the standard deviation is 11.6251. And what is the problem with using the normal z-statistic to establish the confidence interval for the target parameter? C, it is a sample, so you should use the t-score. Find the 95% confidence interval for the target parameter. So you're going to do 1 minus 0.95, which is 0.05. 1 minus 0.05 divided by 2, and that's 0.975. And then you take t, 0.975, and 8 is your degree. I'm sorry, not 8. 1, 2, 3, 4, 5, 6, 7, 6 is your degree of freedom. And then you're going to get 2.4469. So then E, your confidence interval is going to, your confidence interval is going to be 89.8571 plus or minus 2.4469 times your standard deviation of 11.6251 divided by the square root of 7. So I have 89.8571 plus or minus 2.4469 times 4.3939, and then I have 89.8571 plus or minus 10.7514, and then I have the confidence interval is going to be 79.1057, comma 100.6086. And so it says, give an interpretation in words of the interval in part D. So that means that the population mean, or 95% confident it will fall between, we'll say like 79 and 101. I just rounded to the nearest one place. Then it says F, what conditions must be satisfied for the interval in D to be invalid? It must be a normal distribution. Lobster trap placement continued. Now that the lobster fishermen researchers from problem 6.29, we want to know how variable the lobster spacing measurements are for the population of red shiny lobster fishermen in Baja California. What is the target parameter if we're interested in how much trapping space varies? Find the 99%. So the target parameter is going to be to find the confidence interval of the spacing. And for a 99% confidence interval, you have to calculate, again, your t-score. And to do that, you're going to do, so that's A, and then B, you have to do 1 minus 0.99, which is 0.01. 1 minus 0.01 divided by 2, and you're going to get 0.995, and T 0.995, and then degree of freedom of 6, and that's 3.7074. And then you're going to take 89.8571 plus or minus 3.7074 times 11.6251 divided by the square root of 7. Let me fix that. And then we have 89.8571 plus or minus 16.29. And then the confidence interval is going to be 73.5672, 106.1471. So I hope that this video helps. This is the middle school math teacher signing.